Chapter 12, Section 12.2, Objectives. We're going to use Le Chatelier's principle to predict the direction of shift that occurs when a system in equilibrium is stressed. Then we're going to explain the relative change in concentrations of reactants and products as a shift occurs, as a result of a shift. First, we're going to define Le Chatelier's principle. So take a moment and read the passage you see here. And then after you finish reading it, pause the video first, then read the passage and try to summarize it in 20 words or less. Replay that, then press play and see what answer you got as compared to my answer. So if a system in equilibrium is disturbed by changing temperature, pressure, or concentration, the system will shift to regain equilibrium, particularly because equilibrium is the more stable scenario. So there's two things that will occur. A stress will be added to the system, and I'll show you what a stress is on the next slide. And when the stress occurs, your system will either shift left toward the reactants, or it'll shift right toward the products to regain equilibrium. So remember, a reaction is reactants yield products, and in this case are going to be in equilibrium with products. So what we want to predict is the system going to shift toward making more products, or is it going to shift toward making more reactants? So shift left or shift right. And then afterwards, will the concentration of reactants and products increase or decrease based on the direction of the shift? So if we shift it to the left, then the reactants are going to find they're all going to increase, and your products are going to decrease. If we shift it to the right, then it's going to do the opposite. So shifting to the right will cause my products to increase and my reactants to decrease. So let's apply this in the following examples. So here, what happens if more water is added to this system? And water as a liquid is what they're giving us. So I'm going to add more of this right here. If I add to the right side, the system will want to shift toward the left. So you're going to add, whatever side you add on, we're going to shift to the other side. If it shifts to the left, then that means my reactants are going to increase and my products are going to decrease. So both my water as a liquid and energy will result in a decrease after the fact. What happens if more water as a gas is added? So now I'm going to add to the left side. This is going to cause the system to shift to the right, and that's going to cause my products to increase. Both of these will increase, and my reactant to decrease as a result after the shift. Normally, we actually don't write anything under this one because that's the part of the system that we put a stress on. So really, I just need to know that it's going to shift to the right, and these two are going to increase. And you don't really have to tell me what happens to the stress concentration. So what happens if water in the gaseous form is removed? So I'm going to remove some of the water as a gas, so some of the reactants. The system is actually going to shift toward what I remove, which is going to cause everything on this side to decrease and cause everything else on this side to increase. What happens if H2O as a liquid is removed? So if I remove some of this, I'm going to shift the system to the right. We're going to shift toward what we remove. That's going to cause this to decrease and my energy over here to increase. Okay, what happens if heat energy is added? And it's very important to realize that this is when, another way of saying this is what happens if temperature is increased. So we increase temperature. And what this is going to do is it's going to add more energy. And just like if I added the water as a liquid or water as a gas, when I add on one side, it's going to cause everything to shift to the other side. So this is going to cause me to increase the amount of water as a gas and decrease the amount of water as a liquid. If heat energy is removed, or if I decrease temperature, both of those are the same thing, then I'm going to remove the energy from the system, which the energy happens to be on the right side. So we shift toward what we remove, which is going to cause this to increase and this to decrease. Okay, and finally, is this phase change endothermic or exothermic? And because energy is found on the product side, on the right side of my system in equilibrium, it's going to be in exothermic reaction. Okay, a couple more examples. What if more iodine as a solid is added? So if I add iodine as a solid, the system will shift toward the right. That's going to cause this to decrease and this to increase. What happens if more iodine as a gas is added? So I'm going to add more of this. It's going to cause my system to shift to the left. That's going to cause both of these to increase, and anything else on the product side would decrease. What if I remove iodine as a solid? So I'm going to remove some of this. That's going to shift towards what I removed, so shift to the left. That's going to make this increase and everything on this side decrease. Okay, what if I remove some iodine as a gas? Again, we shift towards whatever we remove, so we'll shift to the right, which is going to cause these to decrease. And anything else on the right side would result in an increase. And then finally, what if heat energy is added? That's the same thing as saying, what if we increase the temperature? And if we increase temperature, we're going to add more energy. And adding more energy, because it's on the left side, will cause it to shift to the right, which is going to make my iodine solid decrease and make my iodine as a gas increase. So pause the video and attempt to apply all of those rules to this equation up here. Notice we have nitrogen reacting with hydrogen, and it's in equilibrium with ammonia. So you have nitrogen and hydrogen, and they are in a system of equilibrium with ammonia. These are my reactants. This is my product. If I add hydrogen, it's going to shift to the right. That's going to be, so I'm going to draw a dotted line here because this was the stress. I added hydrogen, so I don't want to include it in my increase and decrease. However, everything on the left-hand side, since I'm shifting toward the right, everything over here will decrease and everything over here will increase. If I add ammonia, so ammonia is my stress. If I add ammonia, it's going to shift the system to the left, and that's going to cause this to increase and this to increase. If I remove nitrogen, so I'm changing the nitrogen, that's my stress. If I remove nitrogen, the system will shift towards what I removed to the left, which is going to cause the hydrogen to increase and the ammonia to decrease. If I remove hydrogen, which is again on the reactant side, the system will shift toward what I removed to the left, which is going to increase the nitrogen and decrease the ammonia. If I remove ammonia, then I'm going to shift towards what I remove, and ammonia is on the right. That's going to, so this was my stress. That's going to cause both of my reactants to decrease. If I increase temperature, and remember, a change in temperature is going to only affect where the energy is, and this is a numeric representation of heat energy or energy. So I am increasing temperature, so I'm going to add to the right side. If I add to the right, it's going to shift to the left, and that's going to cause my reactants to increase and my products to decrease. Opposite of that, if I removed energy, if I decreased the temperature, then that would cause me to shift towards what I removed, so the reaction would shift to the right. And by shifting to the right, that's going to cause me to have a decrease of my reactants and an increase in my products. Given the following reaction, state 3 ways to create more products. So what are 3 ways that I could make this system, which is technically in equilibrium, make this system shift towards the right? And so if I add anything on the left-hand side, remember when we add, it'll shift away, or it'll shift to the other side, the opposite side. So if I add nitrogen or hydrogen, it'll cause it to shift to the right. Also, removing anything on the right side will cause a shift to the right. And so if I want to remove energy, that's the same thing as decreasing temperature. So here are our answers of the possible ways to cause this system to shift to the right.